Okay, so we're going to take a look at the problem that Jim wanted us to take a look at. So there were 5 nodes, 3 interior nodes, and then 1 on the left and right. And when a chip was on one of those nodes, at each turn it would randomly move
Left or right.
left or right. And you're trying to find out what the probability is of the node ending at the left or the right, depending on where it starts.
And when it reaches that end node, the game's over.
Right, when it reaches an end node, it stops. Okay, so how would we use Angle's method here?
Well, we'd have to figure out how to use chip firing.
Okay, yeah, so we're going to try to use chip firing.
Maybe we can use the same 3 chip firing method. And we can give all the nodes... If we give all the nodes 2 chips. And then... Does it say where the thing starts?
Well, he said he did say if it starts in the center, it's equally likely to appear
In either node.
So we want to see what happens when we start off center.
So it starts here, it's equally likely. But
Okay, but why, if it starts in the middle, why is it equally likely?
I guess it's in the center, so it's equally likely to move to the right or to the left.
Okay.
But off center, it's closer to one node than it is to the other.
Right. All right, so let's see how we can use the chip firing method.
Well, we can do some cases. So I guess we have to check 2 cases. What happens if it starts here, and what happens if it starts here?
Okay, and what do you think, how do you think those cases are going to be related?
They'll probably be symmetrical, except that they'll be, like, flipped. So the probability of going left for this one is P, and right is 1 minus P.
Uh-huh.
And the probability of right here is probably P, and the probability of left going this way is 1 minus P.
Okay. Does that make sense?
Yeah.
All right, how do you think we should load the chips here?
Well, the problem.
So I think it would be, we should have 2. We start with the 2 chip thing that we had before. And then the one that would set it off. Although wouldn't there be 2 more things that we need to add chips for, like? Or are we not concerned with the exterior ones?
Well, that's what we want to measure, the exterior
We
one.
want to figure out what the probability.
When it goes into one of the exterior buckets,
The game is over.
the game's over.
So we want to only measure the outside outcomes. We don't want to include any of these.
Okay.
Oh, but if we get the probability of getting... So maybe if we just start with 2 chips on the outside, 2, then that wouldn't make sense.
Maybe we'll have to start with a different number than 2.
Okay, yeah, so that's an interesting question. What did we start with on the prior problem?
We started with 2 chips on every person.
Okay, why?
Because the method that we used, where we needed 3 chips to make it work.
Okay, why did we need 3?
Because
Is one chip...
we needed to set 1 chip to person on our left. We need to send 1 to the right. We need to send 1 out.
Okay. So how many chips do you think we're going to need here?
Well,
So we only need 2, because we would go 1 to the left and 1 to the right.
Okay, so how many chips is each person going to start with?
each starts with 1.
Okay, each starts with 1.
So we
Well, why are you putting chips in the outer nodes? Did we, in our prior problem, did we start with chips in the outer nodes?
No.
No.
So
Okay.
maybe we could try it. We could put the chips on the place where we want to start.
Okay, which one are we going to start
So
with?
let's start with the blue guy.
Okay.
So put a chip here. Fires like that.
All right.
Firing can happen. Then firing can happen again. Put
Right.
another chip on the blue. Firing can happen.
And we put another chip.
Chip goes that way.
That fires.
Then we put another chip on. Hey, we're at the maximum loading position, so
Okay.
it stops.
So it looks like the probability
If of an probability ending over here, it's 3/4.
and the 1/4.
Over here, 1/4.
Ooh, interesting.
And then it would be the same if we started here, but this would just be over there, and that's here.
All right, nice. Okay, great job, guys.
Yeah.
Very good job.